Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is minimum window substring. It's similar to the last one we did, which was the concatenation of all the words in the input array. My first try on that one, I'm trying to avoid some of the mistakes that I made on that one. The first try timed out. The second try, it passed, but the time was so bad that I tried it a third time and got a good time on it. So, among other things here, I'm not going to use actual hash maps. I think the hash maps, cloning the hash maps, comparing everything to do with the hash maps was taking up too much time. So we'll do it slightly different. We'll simulate hash maps with arrays. Let me see the topics here. Hash table string sliding window. Yeah. So I mean it's a sliding window, but we're not going to have any actual hash maps. So the challenge is given two strings, S and T, of lengths M and N, respectively. Return the minimum window substring of S, such that every character in T, including duplicates, is included in the window. If there is no such substring, return an empty string. Test cases guarantee that the answer is unique. Okay, let's look at the, well, let's see. All right, so length of string and pattern can be up to 10 to the 5th. 100,000. All right, let's walk through an example of this. All right, here's the string from example 1. We need a variable to keep track of the minimum window, so we'll initialize it to some very big number, infinity. We need 2 pointers. Well, actually, the first thing we can do is just handle an edge case, which is that the pattern is longer than the string. Now, if the pattern is longer than the string, then we're done. In this case, the pattern for this one is right here, A, B, C. All right, so we need 2 pointers. We'll have one pointer here, beginning of the string, and we'll have a second pointer that goes through the string until we find all the letters in the pattern. So in that case, we have to go all the way to here to get all the letters. Okay, and the window size is, well, before we do the window size, once we find a window, we want to see if we can take characters off the front. Do we have any extra characters on the front? In this case, the first character is an A, and we can't take it off because it's in the pattern. So this is our first window, and we'll get rid of that and change this to 6. Is that right? 80? Yes. Okay. Move the first pointer to the next letter, which is here, D, and then move the second pointer so that it includes all the letters in the pattern. And to do that, we have to go all the way to here, right? Yeah, so we got D, we have A, B, and C. All right, now try and take letters off the front. Can we take letters off the front? In this case, yes. We can take off the D, we can take off the O, we can take off the B because we have too many B's. We only need one B, and that window has 2. So we can take that off. We can take everything off down to here. All right, so now we have a window with all the letters, C, O, D, E, B, A. That's also 6. All right, it didn't get any smaller. Next, move the first pointer down one, and we'll go to here, the O. And in order to get all the letters in the pattern, A, B, and C, we're going to have to go to the end of the string here. All right, again, we're going to try to take letters off the front, which we can do. We don't need the O or the D or the E. So we can take it off to here. And now we have B, A, N, C. That is smaller than the minimum window that we had before. So we'll go with 4. And that turned out to be the answer. That's the minimum window, B, A, and C. So let's take a look at the code. Okay, so as I mentioned, the first thing that we want to do is say if s dot, I should slide this window over a little bit. Slide that, and maybe there's a little more room there. All right, so we'll say if s dot length is less than, if the string length is less than the pattern length, we're done. So we can return an empty string. All right. Now we need hash tables, or hash arrays in this case. So let's do int hash pattern equals new int 256. Why 256? Because we have we're storing input characters, and a character is a byte, and so it can have a character code between 0 and 255. So it should be good on that, and then we'll have one called hash string new int 256. Okay. We want to put the pattern, the characters from the pattern, as well as their number of occurrences into hash pattern. So let's do this for int I equals 0, I is less than t dot length I plus plus. I guess I could do this with an enhanced for loop, couldn't I? Hash pattern at t dot char at I, and we will increment that. All right. So we've got the hash, the hash table for the pattern loaded. We need some more variables. Start. We're going to start at index 0. We're going to have one more variable here. This is really just like a flag. If we get through the whole process and start index is still equal to -1, that means we didn't find anything. What else do we need? Int min length equals integer dot, no, integer dot max value. Actually, we need one more. We need a count, initially 0. So when as we're traversing the string, if we find a letter that's in the pattern, we're going to increment the count. And when the count equals the pattern length, then we know that we have found a window. Okay. Now we can start the loop over the string. We can start traversing the string. We need a second index here. Int. Let's say j equals 0. J less than s dot length j plus plus. I'm just incrementing this by 1. I mean, in walking through the example, I kind of jumped this index ahead a couple of times, which, I think we could do, but for one thing, I don't like to tinker with the value of a loop index inside the loop, and for the other thing, I'm a little nervous about it. I mean, I'm pretty sure it'll work this way, and if I start jumping the index, I'm not sure exactly what's going to happen. So let's at this point say hash string at, that would be s dot char at j plus plus. All right, so we're looking at the first character of the string, and we are incrementing it in the string hash map. Now we want to see if that character matches a character in the pattern. So let's do this. If hash string, I could copy that really. If hash string char at j, this is going to get kind of long. Let's try it. Is less than or equal to hash pattern same character as char at j, then increment the count. We found a matching letter. Okay. Let's see. Hash string s char at j less than or equal to. Yeah, if it's not less than or equal to, it means we already used it. We've already used it enough times, so we're not going to increment the count again. We saw that in the example where one of the windows had multiple b's, so we don't count it more times than it's actually in the pattern. All right, if count equals t dot length, that means we have matched all the characters. If that is the case, we're going to try to take characters off the front of the window while hash string s dot char at start if that is greater than hash pattern and same character. Whoops, too fast. Hash pattern All right. That means it is in the pattern, but we've used it too many times. So we can take it off. There's another possibility. We'll say or hash pattern. Can I paste that again? Schar at start equals 0. That means the character we're looking at is not in the pattern at all, in which case we can also take it off. There's a better way to do this. While, all right, so we have that. Let's back it up a little bit because we need an if statement here. Let me think about this for a second. Okay, no, I think we have to leave it like this. But let me copy that and put it down here. Whoops, not there. Put it here as an if statement. If we have too many, if we've used the letter too many times in the window, if the letter is in the window too many times, then we need to decrement it from the string hash table. So, let me copy this again. Okay, start, and that is going to be a decrement. You know what? I need a bracket over here. All right, I need that. Okay, that closes the if. And I need to close the while. I need to close the while. No, something got confused there. Oh, wait. No, see, that's not what I want to do. I think this is okay. Yeah, it matches the right one. Okay. Okay, what did we just do there? Well, in the example, in one of the windows, there were 2 B's in there. And we only need 1 B. So when we started taking letters off the front, we could take that extra B out. But we also have to decrement it in the string hash table. Otherwise, we may wind up deleting it too many times. Okay, so that's if they match. Update the window size. What is our window size? So if we're in here, if we're in this count equals length, that means that we have a window. We have a window. So let's do int len window equals j, which is our right-hand pointer, minus start plus 1. And if min length is greater than len window, we've got a new winner. So min length becomes len window. Okay. We also set start index to start. So that tells us that we found something and where we found it. And that really should be it for the loop. Where does the loop end? Right here. All right, so we're out of the loop. First thing is let's check if the start index is still -1, because if it is, then we didn't find anything. All right. If we did find something, we're going to return s dot substring. The substring will start at start index, which we saved, and it will go to start index plus min length, not inclusive. That's it. Let's take a quick recap. All right, so we have a hash map of the characters in the pattern. We're going to loop through the string. We have one pointer starts at the beginning. Well, both pointers start at the beginning, but the second pointer, the J pointer, traverses through the string. It counts every time it sees a letter that we need for the pattern. And when count, or if count, equals the length of the pattern, then we found a window. All right. We start taking characters off the front of the string if we can, either because they're not in the pattern or they are in the pattern, but they're in the window more times than they're in the pattern. Let's see, calculate the length of the window, check and see if it's the minimum window length, keep the start index. I don't know. That looks pretty good. Let's try it. Move that and run. Compile error. What happened there? Expected another parentheses if hash is while. Oh, I see. Or equals 0. Oh, it's here. If, so that's open. I gotta close the if, right here. All right, let's try it. File error. These things would run perfectly first time. Int cannot be. Oh gosh. All right. Yeah. Okay. Int hash pattern. Int hash string. All right. One more try. Wrong answer. ABC is even in here. Okay, logic error. I never incremented the start. Count equals t length. Start when there's a match. We've got to increment start. All right, now let's try it. There it is. Okay. Move that out of the way. Let me scoot the frame over. Open this a little bit. Submit. Okay. That is good. Let's see, 6 milliseconds. That actually looks like the best. Oh no, there's actually some that use 3 milliseconds. Well, okay. So that should be an O of N solution. Okay. All right. That's it. It's not an easy problem. But feel free to like, subscribe, and see you next time.